today. I really appreciate it. I know it's the last one, and that's the end of the day. If you do have to leave during my presentation, or if I don't get to all of your questions, I do have business cards back at my table if you want to take those on your way out. So my presentation is the trash turtle for this year, but before I get started on that, my name is Aspen Roethe, for those who don't know me. I work at Mod Pizza. I'm a woman in STEM officer. I am also part of the VEX robotics team here at Grandview and part of TSA. I have also done Destination Imagination for over 11 years, and I am a Scholastic Art and Writing Award winner. Now, my passion for the environment started when I was really little, just from picking up trash off of the ground to writing handwritten letters to the government and getting responses back from congressmen, governors, and even the president at that time. Currently, I've been vegetarian for 6 years. I also drive an electric car, and I have committed to University of Oregon to double major in marine biology and environmental science. Now, on top of all of that and the Capstone project, I've also spent the last 4 years creating marine biology artworks, also raising awareness about issues in the environment like bycatch and plastic pollution, they are actually displayed in the lower comments if you want to go down after this and check it out. So now getting into my actual project, my inspiration, along with just like in general my love for the environment. I also saw this video.
Where are you going? Let's slow down.
This video at the beginning of the school year, and I found it on Instagram, and it was just really inspiring because I saw just how much plastic is in that, and I also found the fact that 100 million marine animals die each year from plastic waste alone, and most of that is found on the beaches before washing into the ocean. So I wanted to have a solution that could help with that. So my original idea, I wanted to call it the beach bot, but that was unfortunately taken, so I wanted to name it the sand bot and found that trash turtle was even more catchy. But originally I just wanted the idea to have a fully working robot that can drive on sand and pick up trash while dumping and leaving the sand behind. I wanted to make it as, easy as possible and least harmful for the habitat. I also wanted 2 shaking tables. My initial idea was to make 2 shaking tables that would shake and have the sand fall through while the trash goes into a bin later, but that changed. So my project objectives, I wanted to build a working robot, obviously. I also wanted to learn SolidWorks and learn Python and also Arduino because that was what I was going to be using. I wanted to build relations in the engineering and conservation world, and I also wanted to raise awareness for plastic pollution, which is what I'm doing right now as I'm talking to all of you guys. I also just in general wanted to work on my engineering skills. Even though I'm going into a marine biology major, I still want to have that aspect still in me. Some of my research goals, again, I wanted to relearn SolidWorks, learn how to better use it and be more effective with it. I wanted to learn Python and Arduino, as I knew very little at the beginning of the year. I wanted to learn about habitat harm and how I could build a robot that would cause the least amount of damage to the habitat while still getting my goal done. And for most of the year, I spent researching suspension. So my biggest problems, first of all, the sand. From it getting into motors and trying to find motors that could fit into the motors and have sand not get into them, to gears and shifting tables and making sure that the sand doesn't get stuck in that. Also the weight of the sand, or the weight of my robot on the sand and making sure it can drive around while still doing that. And also just the bumps and getting over the bumps in the sand that are naturally occurring. Also autonomous. If I wanted to use sensors, if I wanted just to code an area for it to go around on, or if I wanted to use a joystick. And then my last biggest problem, that was actually my biggest problem throughout this year, was the suspension. Everything about it, from keeping the wheels straight so it can actually drive, to also making sure I can bear the weight of my robot. So before, I needed a panel of advisors. So my first one was Matthew Beaker. He works at Heister Yale. He is the Director of Global Emerging Technology Products, and he's an electrical engineer major. I also have Mr. Barker, over there, and he's our robotics and engineering teacher at Grandview, and he's also our VEX robotics coach. And then also another one is Kevin Roethe. He's an electrical engineer. You're a mechanical engineer, actually. No, you're an electrical engineer. I knew that. He's my father, I should know this. He's also a general in the Air Force. He has done MIT AI coursework, and he coded a navigation system. I also needed support advisors for this. I had Danny Diaz, he's at the School of Mines, and he's a mechanical engineer and is very good at computer science. There's Corey Patheeks, and she's a grad from University of New Hampshire, and she's a marine, estuary, and freshwater biology major. And there's also Gwenny Dubenhugger. She's my German exchange student and sister, and she's my emotional support buddy throughout this whole thing. So my original schedule, really the main important thing to focus on this is me wanting it to be done February 9th. In reality, I got it done last Friday. So a more realistic schedule and what actually ended up happening is this. As you can see, I spent a month on SolidWorks. I also spent multiple months on the suspension and a month on brushes. So it took a while to get this done, more than I was expecting. So at the beginning of the year, I wanted to 3D print almost everything, from just like the suspension and just in general almost all of it, because I knew that metal would be heavy. So I have a 3D printer at home, and I started printing PLA filament. It was actually a like rainbow filament, and it's very, very expensive, but it worked good on my printer. But I didn't want my project to be rainbow, and I also didn't want it to cost that much. So I switched to ABS, and as you can see in this lower image, it was absolute chaos. I did a little bit of research on that, and I tried a bunch of solutions, and I found out that it would be better if I just switched back to PLA. So I got some PLA, and then I did a little bit more research. I doubled my printer, I taped it, and I put Elmer's glue on it to help it stick to that bed, and it ended up working pretty well. Around that same time, I was also doing some research on suspension. My idea was to go off my remote control car that I have at home. And with the 2 arms and the shock absorber to help make sure that I could bear the weight while still going over these bumps. So I got some initial objects to work with. I got my initial wheels with a lock nut in it, as you can see right in here. I got the shock absorbers, and I went to go order these arms. I wanted 2 for each one, but I ordered 1 pack, and then I went back to order another one, and they disappeared off the face of the internet. I could not find them anywhere. So I had to do a little figuring out for that, which I'll show in the next slide. So I also was working on SolidWorks. I had to relearn it, and as you can see, I wanted to work on the part that could hold my motor, which the motor is right in the middle, and it's not a great place to connect. So I had to create something that it could hold that motor and connect to the suspension. So the first attempt was that up in the top corner right there. It was way too thick, but I was just messing around with SolidWorks, how it would transfer and print onto the 3D printer, and how I would get that. Then I went on to my second attempt and made it much thinner, and I quickly realized that I needed a second point to attach a second arm to make sure that those screws were level. So then I went on to my third attempt, and you can see that I have the 2 suspension arms over here, but this is when I found out that I could not order the same part twice because it was gone. So I went into that final one that is actually on my robot right now, this one, to attach to the part that I did end up getting. So this is my initial idea for the suspension. You can see I have the shock absorber, the 1 arm, and that which would hold my motor. And I ended up needing a second arm, like I said. So around the same exact time, I was also building my frame. I was using Beck's parts because I was part of the Beck's team, and I was comfortable using those parts, and also they were easily accessible at the school. I quickly realized that it was also very, very heavy, so I needed to print almost everything else. So I also went ahead and kind of prototyped a part for the shaking tray, and knew that the idea that I wanted, as you can see there. And then also around the same time, I was kind of jumping around a bit on my project. I was also working on that wiring. So I soldered a control panel to one of the motors. I attached it to an Arduino board, and I got that connected to a little joystick just for testing. That was connected straight to the Arduino board. I also had the idea to use sensors. I wanted to use sensors for this robot so I didn't have to drive it around and be there. But I quickly found out that with some talking to my advisors and some research, that sand was very, very reflective, so I couldn't use any vision sensors as I would get a bad input. And then I also was thinking about using GPS, but because it was the ocean and by the beach, the tides and other aspects like humans would get in the way and just run into that or into the ocean.
Go too far. Up.
Okay, don't pay attention to any of that. You saw nothing. We'll get there. There's a lot of slides here. Don't pay attention to that part. I think I was actually here. So then, ignoring that, I went to go test it, and you can see it's moving just forward and backwards, and I was just using a little joystick. And then I had attached 3 more motors to that, and I attached control panels that attached it to the Arduino board, and put it all into the suspension. And as you can kind of see here, the suspension is bending inwards, which is it's not supposed to. It's supposed to stay straight, but that was another one of my big problems. But I went to go test the motors, and as you can guess, it didn't go too hot. I decided to test it on the metal frame, and without thinking, I didn't take the bottom of my power distribution board, and I connected that battery straight onto that metal frame and caused it to short circuit. So the entire thing went up in smoke. I quickly unplugged it, had a little panic attack, thought about it, and re-soldered a power control board because that's what I thought was broken. And went to go test it with the same exact battery. And like expected, it didn't work. So like any normal human, I went into my room, had a quick mental breakdown, and while staring at the wall, I kind of thought about it and saw the smoke coming also off of the battery. So I tried a new battery, and this is what happened. As you can see here, the motors were moving left and right, forward and backwards. You can also see I was a little scared about it touching the metal again, so I taped the whole entire thing. And you can also see that the motors are a little wobbly, but I went on to fix that in a later slide. So that was around midpoint, and I ran into a lot of problems. First of all, the frame wasn't big enough. The suspension ended up taking way too much space than I was originally planning, and I needed something bigger to actually have either a shading table or whatnot. It also looked really messy. It was my first prototype. I was just kind of tinkering around, and it ended up just looking pretty bad for a capstone project. And also, as you saw in the previous slide, the suspension was not level. They were all tilted inwards, which would cause too much tension on the motor, so it wouldn't actually move it. And then also the logistics of the shading table and getting sand in those joints and it not being able to work. So then I came up with a brilliant idea. If I was going to call my robot basically a sand Roomba, I should maybe use some parts of a Roomba. So I didn't actually need a shading table. I just needed something to sort plastic from sand. And I got the idea off of a Roomba. I just needed enough brushes that the plastic would stay on top and the sand would fall through the brushes. So I went ahead and got an actual Roomba brush from a Roomba, and I SolidWorks some parts. I did this top one is connecting to this top run right here to the motor so it can turn, and then I also connected this part right here to the bottom, as you can see in that lower picture, to hold that to the frame while it spins. And that was actually my first part that I measured it and printed it and got all of that done first try, and it fit perfectly without a millimeter to spare. So then I went on to build a new frame. I quickly realized that it was too small and I needed something to fit the brushes. So as you can see here, that is the final frame that I ended up using. And you can see in these images, I made it way bigger, almost double the size. I also built new suspension holders because at that point I was connecting the suspension to the robot with jewelry wire, which was not a great idea. So I 3D printed some other parts and attached it to the robot to make that suspension more stable and got it to stay straight as well by keeping the two arms parallel with each other, which wasn't a big problem at the beginning. So here's a video of the new suspension of it working with the wire. With some gorgeous music in the back. But that point, and you can see the wheels are slightly more wobbly, so I ended up getting new wheels as well, because first of all, the connection point from the motor to the wheel was wobbly, as you could see. And then also the 3D printed part that was holding the motor was about the same size as the wheel. So they were both dragging on the ground, which was not a good idea for sand. So then I went ahead and I attached the brushes. I made 3 because I figured that that's how much space I had, and also that would be enough for the sand to drop through. And here is a video of me kind of explaining it kind of with my hands, just how it would look like and what I wanted that bigger brush to look like, because I figured that if the brush was attached all the way at the bottom, it couldn't pick up that larger piece of trash, but if it was attached all the way at the top, it couldn't pick up all of those smaller pieces of trash as well. So I wanted something that was slightly adjustable so it could pick up different sizes of trash as well. So that's kind of a little video of me explaining that. And then I went on to, kind of at the same time, I went on to coding. I decided to still stay with that joystick, just remove it from the Arduino board and attach it to a transmitter. So that's basically the transmitter code. I won't get too much into it, but that's just me programming it to send a message from the transmitter to the actual robot. And then this is a setup code, so basically just telling the code which pins are what and how it will run. And then this code is basically just saying if I press the joystick forward, the robot will move forward, backwards, left, and right. And also if I press that button down, it will turn on the brushes. So then, I had a 3D printer fail. Don't trust everything you buy on Amazon. That was, as I was printing, and you can see I printed a lot. I was printing pieces over and over again. I was barely turning the 3D printer off. I was just constantly printing, needing to get this project done. So I ran out of filament and jumped on Amazon, ordered the first thing I could find that would ship overnight, and it came out like this. If you can't tell, this is supposed to be completely solid, but it pulled apart those biscuits that you have at dinner. It didn't go very well, so I jumped back onto Amazon and I got a new filament that is more reliable than I was using before. And then I killed my 3D printer. Like I said, I was using it non-stop. I was running it and running it and running it, and it started to mess up. And I didn't really know why, so I did a little digging around and found that the bed heaters are broken. And basically on a 3D printer, the bed's supposed to be hot so that 3D print will stick to it, and it wasn't, so it kept popping off. And it was actually creating this. This is not usable. So I did a little research on how to fix it. It basically said, plug it back in, like try pulling out, plugging it back in, checking all the wires, and then smacking it a few times. So I plugged it back in, I checked all the wiring, I hit it a few times, then hit it a few more when it wasn't still working, and then bought a new 3D printer. And then they gave us a new 3D printer. I built it, and it didn't work. It just kept up coming with errors and malfunctions, and I was like, I swear I built this right. I did. They gave us a faulty printer. So I did some research on how to fix that, basically, and it basically just said buy a new printer. So I did, and you can see this is the new printer over here, and it works amazingly. Okay, and then also around the same time, I was messing with the robot, trying to get all 8 motors to work, as I needed 4 for the brushes and 4 for the wheels. And I was using these little control panels right here. And it turns out they kept burning out faster than I could solder them. And I did a little research, and it turns out they can only hold 10.8 volts, and I was using a 12-volt battery, so they were burning out constantly. So I quickly switched to a new control panel that could hold 24 volts and control 2 motors off of the same one, and attach those onto the robot. But as you can see here, I have a bunch of these little failed guys. And then I went to go and test the driving. As you can see here, it moves forward, backwards, left, and right a little bit. And I was very impatient, so I did not attach everything. I just threw it all into a bucket and slapped it on top. It was a fire hazard, but nothing caught on fire. And then also you can see those 2 metal parts right here and here are dragging onto the floor. And I did just a little bit of tinkering, basically switched that upside down and made sure that they weren't dragging on the floor anymore. So then I went to test the brushes without the robot moving. I just wanted to make sure the brushes worked. And you can see here that it picked up a little 3D printed part and got it all the way across. And I just fed it different types of plastic and different types of trash just to make sure that it could pick up almost everything. And it did. So then before I show you the final result, throughout this entire project, I said that I would take 5 steps backwards and 8 steps forward. And to be honest, it was a huge learning experience for myself, for this project, and also just for an engineering process as well. And some weeks it felt like I was taking like 20 steps backwards and no steps forward, and some weeks it felt like I was only taking 2 steps forward instead of normal progression. It was always something to learn. As you can see, I have my bucket of fails of everything that just kind of went wrong. But in the end, it always turns out good. So I present to you the final working trash turtle. Of it fully moving, has full suspension, it can pick up trash exactly like I planned it to, and it deposits in the back with no sand, and it fully works.
Yeah.
Are there any questions? Yes.
Would you try to make this something that can be autonomous or at least controlled from a base station?
Most definitely. This is not a finished project. I would love to expand on it and build it more from the size to also having sensors on it so it could run without any control. Yes?
Speaking on expansion, do you plan on working on this when you're in college?
I plan to, yes. I do definitely want to work on it in college, and I'm hoping to find a professor at the school or finding a few more advisors to help me fund and make it bigger and better. Yes?
How loud actually is it? Because from the demos, I know if I was sitting at the beach and I heard that, I would freak out.
It's actually quite quiet. We were just blasting music while testing it. Like my dad was with me while we were testing it. We were just blasting music as well. So it's actually quite quiet for a moment.